Hello, Coach Holmes here, and today we're going to be talking about a new unit on probability. But today we're going to be focusing on theoretical and experimental probability. Now, what do we mean by theoretical probability? Basically, it's a theory, okay? It's the type of probability that is based on math theory. Okay? And what I mean by that is that it's pretty much it's just thinking about the possibility or the chances of getting something. So for example, if I think of numbers between 1 and 10, what's the probability of picking an even number? Well, there's 5 even numbers out of 10 possibilities, 5 out of 10, which is basically 1/2, 1 out of 2 chances, or even 50%. That's theoretical probability. It's just thinking of the chances you will get to pick an even number. Now, what's experimental? It's the type of probability that is calculated after performing an experiment. Okay? So basically, if I actually did the experiment, like for example, if I'm still doing the whole picking a number 1 through 10, if I just pick a number, that's experimental. And if I keep doing it and doing it and doing it and doing it and doing it, then I eventually figure out what were the chances. What did I come up with? Like for example, if I would have done it 50 times, I can get 48 evens and 52 odds. That's experimental probability. I did the experiment and this is the results that I got. That's experimental probability. Now it may not always come out even at first, but the probability is that the more often you do it, the more likely you get to the theoretical probability as far as the actual results or the actual possibility. Now, when tossing a coin, for example, and this is just one example. When tossing a coin, what's the probability of it landing on heads or even tails? Well, for example, really, if I look at a coin, there's 2 sides of a coin. There's either a heads or a tail. So really, for heads, there's 1 out of 2 chances. And for tails, that's also 1 out of 2. So really, truly, there's a 1 out of 2 chance that I can actually get a heads or tails. Now, if I do experimental, and I know I got a coin here. If I do experimental, I can do this several times and figure out the probability. So for example, let's say we do this about 10 times. So what I'm going to do, heads, tails, so I already got tails. Tails again. Heads. Heads again. And this is what I mean by experimental. I'm actually testing the theory and figuring out what the chances are. And as I go along, I actually will determine out of 10 chances what the results will be. And so far, it seems pretty even. and it's dead on. So out of 10 chances, we got a 50-50%. We got 5 out of 10, 5 out of 10. Okay? So experimentally, it can work, but let's be honest, if I would have tried this again, we may actually get 6 heads and 4 tails. But it worked out for us. But that's what experimental does. It gives us a possibility of determining how close can we get to the theoretical. And again, there's different ways to do the experimental. So now let's look at another one. There are 6 blue marbles, 4 green marbles, and 2 red marbles in a bag. What is the probability of pulling a green out? So let's think about this. First of all, now it's not as clear cut, okay? Because we know with a coin, we know there's 2 sides of a coin. So what we want to do, we got to determine the total. So 6 plus 4 plus 2 gives me 12. So something out of 12 is going to get me green. So for blue, there's 6. Green, there's 4, and red, there's 2. Okay, and I can do it for all of them. But if I really think about this, there's 6 of the 12 are blue. 4 of the 12 are green. 2 of the 12 are red. But if I simplify the green part, that's a 1/3. Yeah. So 1 out of 3 chance, there's a 1 out of 3 chance that I would pull out a green marble. 1 out of 3. There's a 1 out of 3 chance. Now if I do the experimental, which I don't have blue and green marbles with me, but what I do have is a random name generator. Okay? And what I mean by that is that I can actually, on my computer, list out 6 blues, 4 greens, 2 reds, and all I have to do is just pick random, and it will pick one for me. So we can do this about 15 times. And I'll try to make it quick. Just depends how fast this computer will go for me. But if I really think about it, looking at it, there's a more likely chance that I will pull out a blue. If I really think about it, what's more likely am I going to be able to pull out? I'm more likely going to pull out a blue. And so far, experimentally, that's why I'm pulling it out. I'm just pulling out blues. I haven't pulled out a red yet. And I only pulled out 1 green. Pull out blue again. Here's a green. So that's 6, 7, 8. Number 9's. And I just realized I put blue in twice. That's how more often I get blue. Silly me. 10, I believe. No, this is number 10. My fault. Number 11. Five, 6, 7, 8, 9, 10, 11, 12. 13's right here. This This is number 14. And then lastly, 15. Right here. So looking at this experiment, I got 7 out of 15 for blue, 5 out of 15 for green, 3 out of 15 for red. Now, looking at it, and guess what? 5 out of 15 is the same thing as 1/3. So even then, the probability of getting green works out. But if I look further for blue, that's 1/2. And red is 1/6. So really, we were definitely more likely to get blue, and we actually got red a little bit more often than we expected. But if I keep doing the experiment if I keep going on with the experiment, I'll eventually get 1 out of 6 for red, theoretically speaking, if I keep doing the experiment. Now, lastly, we're going to have numbers 1 through 10, but what's the probability of picking 3 through 5? Well, let's think about this. 3 through 5, there's 3 numbers. There's 3 numbers between 3 through 5 because there's 3, 4, and 5. 3 possibilities. Okay, that's what we're going to say. We're going to say 3 possibilities. So for 3 through 5 and not 3 through 5, there's a 3 out of 10 chance, 7 out of 10 chance. Okay, so what I want to be able to do is what's the chances of picking 3 and 5, or 3, 4, and 5? Because any other number doesn't matter. I want to know, I want to get 3, 4, and 5. So again, if I do the experiment, what are my chances? So I'm going to do this. I'm going to do this about 10 times. So I got 8. That doesn't work for me. 1. 2. 3. And oh, by the way, this also comes in the fact that I put the numbers back and I can pick the same number twice in a row. Just like the marbles. With the marbles, I can put the marbles back in and keep on picking the same one. 5. This is number 6. Wait, by the way, I got 7 and 7 and 2. I got an 8. This is number 7. It's a 9. Number 8 is going to be, it's going to be a 3. 1, 2, 3, 4, 5, 6, 7, 8. Number 9 is right here. That's number 10. And last but not least, the very last number we're going to pick is a 4. So, and this is just kind of funny, all 3 experiments the one we're trying to look at works out as the actual probability. But like I said, it doesn't always work out that way. Because if I look at this, that's 3 out of 10, and this is 7 out of 10. So the probability are actually the same. But again, we can do this experiment over and over and over, and it's not, as far as low numbers, like 10 to 15, like what we were just doing, it doesn't always work out that way. It doesn't always work out perfectly. But again, if you think about large numbers and keep on going, you actually get the probability that you're looking for. So what I want you to focus on today, and what I really want you to worry about, is what are the chances? What are the chances of getting the results that you're looking for? What is the probability? Because you got to think about the number of possibilities, the number of possibility that you're looking for, and divide those two out, and that gives you probability. Thank you, and have a good day.